Hello, good evening everyone. Welcome to BYJU'S exam prep. So let's start the session which is related to your revision of nothing but a very favorite topic, that is Laplace transform. So let me know whether the voice is clear or not. Yes, so the voice is absolutely fine. Yes, voice is absolutely fine. So let's start the revision session for this. And before starting the session, let me introduce myself. So this is Saket Verma, and I'm having more than 13-year experience. Okay, so this is 13-year experience, and I have done MTech from IIT Guwahati, and I have taken a different PSU exam as well. So my area of expertise are electromagnetic theory, communication system, advanced communication system, signature system, and ICT. These are the subjects which I usually teach, and for other subject also we can have the discussion, right? So first of all, you should know that we are bringing a new series. We have brought up this new series actually, that is the BYJU'S Exam Premier League. Okay, so that is the Premier League where there will be a competitive environment for all of you, where we will be discussing the concept in the YouTube and followed by the app. So once you start the session in the YouTube, you will learn the concept and then we will take the quiz on the app. Okay. And then after that, you should know that we have the scholarship test every Sunday at 9 a.m. morning. So if you want to register yourself, then you can register by the link given in the description. And you should always aware about this scholarship test, because the full course you can get with very low cost. Okay. Now coming to the main part, that is the Laplace transform. So what is the definition of the Laplace transform? We generally calculate the Laplace transform for a periodic signal, though we can calculate for all kind of signals like bounded and unbounded both. And the Laplace transform of x of t, any signal Laplace transform x of t is given by x of s integration from minus infinite to infinite x of t e to the power minus st dt. So this is the Laplace transform definition or the formula. We convert the signal from the time domain to the S domain using the Laplace transform, because we have to revise it in the short time. So we have to discuss only the important points about the Laplace transform. Because we are integrating from minus infinite to infinite, it is called as the bilateral Laplace transform. Okay, and just a second. Now, what is the region of convergence? Whenever we define the Laplace transform, we have the region of convergence as well. And the region of convergence says that you have to define the range of the Laplace transform where it will converge. So the value of S for which the Laplace transform converges is called the region of convergence. So here you can see there are few important results where we can write the Laplace transform. E to the power minus 80 ut. E to the power minus 80 ut has the Laplace transform 1 upon s plus a, where the sigma is greater than minus a, or you can also represent it as a real part of s greater than minus a. So when the signal is right sided, because this is the e to the power minus 80 ut, so if the signal is right sided, then the Laplace will have the region of convergence as a greater than sign. So real part of s greater than minus a. Here also e to the power 80 ut, this will also have the real part of s greater than a. Okay, so that is the region of convergence for the right hand signal. So 1 and 3 are the right hand signal. U of minus t, that means you are performing the folding operation. And if you are performing the folding operation, then definitely it will be a left hand side signal. And if it is a left hand side signal, so this is real part of s less than. So whenever it is a left hand side signal, you have to use the less than sign. So that is the real part of S, less than, minus, sorry, plus. So these two are the left hand side signal, and these are the important result for the signal e to the power minus 80 ut. So most of the questions you will see in the form of e to the power minus 80 ut. Now, coming to the Laplace transform, suppose you calculated the Laplace transform and it comes as a rational function in S. That means it is designated as the numerator and the denominator. Okay, so it is in the form of numerator and denominator, where a numerator and denominator will have the function of S, and there will be some zeros and the poles for this particular function. Then for the proper rational function, if the n is greater than m, okay, whenever the n is greater than m, whenever here, whenever the n is greater than m, we will call it as a proper rational function, and whenever the m is greater than or equal to n, we will call it as a improper rational function. So the value of s for which x of s is 0, the value of s for which x of s is 0 is called as the zeros of the function, and whenever the value of s for which x of s is defined as infinity, we have the undefined. That means x of s is undefined. That means it is a nothing but the poles of the function. X of s does not converge at the pole, because when you put the value of s for which it becomes infinity, so that will definitely not converge because the value is infinity. The convergence means that the value should not be infinite. It should always have some finite value in the region. So it means that the ROC will never, the pole will never lie in the ROC. So ROC does not contain the pole. On the other hand, 0 may lie or inside or outside the ROC. So 0 may lie inside the ROC or outside the ROC, but the ROC will never contain the pole. Now, when the Fourier transform will exist, because when you talk about the Laplace transform, so you can directly jump into the Fourier transform, or you can define the Fourier transform through the Laplace transform as well. So, when you will say that if the Laplace transform of any signal is existing, then whether the Laplace Fourier transform will exist or not. So, for that, when you calculate the Laplace transform, you will find the ROC also, because the ROC is compulsory. Why? Because the Laplace transform should converge. So when you will calculate the region of convergence, that is ROC, if the ROC will contain the j omega x's, then you can call it as a Fourier transform also exists for the given function. Okay, ISRO communication video, you have posted a doubt. So, Pratim, if you have, you can post that doubt in the comment section here also, in the chat box. So, I will be able to answer it right now. If you can post it, please post it right now. Okay. And the properties, what are the properties of ROC? As I said, that ROC does not contain the pole, and ROC will have the ROC of x of s consists of a strip parallel line parallel to the j omega axis. So it will consist a strip which is parallel to the j omega axis like this. Suppose you have the pole over here. This is the j omega axis. This is sigma, and suppose this is the value where the pole is existing. So this is the parallel strip you are getting, which is parallel to the strip you are getting, which is parallel to the what, j omega axis. Okay, so this is the meaning of the first property of ROC. The ROC will not contain the pole, and if x of t is of finite duration, if the x of t, the signal is of finite duration, then, and it is also absolutely integrable, that means you can say it is bounded, then the ROC is entire S-plane. So the ROC will be entire S-plane for the finite duration signal. Okay, like a finite duration pulse. If suppose this is the rectangular pulse, suppose this type of pulse we have, like delta t, like this. So for this type of pulses, you can say that it is having the entire S plane ROC. Okay. Now coming to the next property, that if the signal is right-sided, then how do you calculate the ROC? So if the signal is right-sided, then there will be multiple poles in the, suppose in the Laplace transform, then the ROC will be the rightmost of the rightmost or outer of the rightmost pole. So ROC is the, for the right hand side signal lies to the right of the all the poles. That means right of the rightmost pole. So suppose you have the multiple poles like this. Okay, suppose you have the multiple pole like this. Then in this case, what is, and if the signal is right sided, then what is the strip? That is the right side of the rightmost pole. So that is the right side of the rightmost pole. You cannot have the ROC like this, because if you will take the ROC in this way, this ROC will contain the poles also, and we have already written that the ROC will never contain the pole. So, Pratim, actually, if the filter is having the cutoff frequency 1100, it means that the you are saying that suppose we have a low pass filter, and the low pass filter is having the cutoff frequency 1100. So the function of the low pass filter is only that it will allow all the frequency, okay, it will allow all the frequency less than 1100. That is the function of the low pass filter, na? That is the function of low pass filter. So why you are having the doubt? That is just simple concept of the low pass filter. The function of the low pass filter is it will pass all the frequency which is less than its cutoff frequency. Okay, the low pass filter will look like this. The low pass filter is having the function like this. So it is minus 1100 to 1100. So it will pass all the frequency which is less than 1100, and it will reject all the frequency which is greater than 1100. Cutoff frequency means different for the different case. It is not always meaning that the cutoff means the minimum value. For the low pass filter, cutoff means the frequency which is maximum actually. For low pass filter, it is a maximum frequency which it can allow. For high pass filter, it is the minimum frequency which it can allow. Okay, so there is a different meaning for the different type of filter. The function you should study, understand. First of all, you should understand the function of the filter. Filter is nothing but the to filter some frequency. And if I am saying low pass, so by the name itself, you can understand that this is low pass. That means it will pass only low frequency. If it is high pass, that means that it will pass only high frequency. Okay. Now the fifth property of the ROC is if the signal is left-sided, then the ROC will be the left of the leftmost pole. Left of leftmost pole. This is the example of the left-sided signal. And if the signal is finite duration, if the signal is of finite in x of t is an infinite duration which is neither right sided means if the signal is both sided. Okay, two sided means both sided means it will have some part in the negative side and some part in the left hand side. Okay, negative side and the positive side. Then in this case, the ROC will have the strip between the two poles, sigma 1 and the sigma 2. Sigma 1 and sigma 2 are the real part of the two poles, or we can say that the ROC consists of a strip in the S line, S plane. Now, summary about the ROC. Whenever you see the finite length signal, your ROC will be entire S plane. Whenever you see the left side signal, the ROC will be the left of the leftmost pole. And if the signal is right sided, then it is right of the rightmost pole. And if the signal is two sided, that means positive and negative it is having, then it is having the strip of finite width. The ROC will have the strip of finite. Now coming to the property of Laplace. We have understood the property of ROC. Now let's come into the property of Laplace. So linearity property says that if you have any signal x1t, its Laplace transform is x1s and ROC is R1, and x2t and having the Laplace transform x2s and ROC is R2. Then if you multiply these constant a1 and a2 in the signal x1 x2 and add them, then their Laplace transform also get multiplied with the same constant and added together. So you are multiplying a1 with this and a2 with this, and you are adding these two signals, then the Laplace transform will also multiply with an and a2, and you will have to add these two signals to get the Laplace transform of these two added signals. Okay. Second property says the time shifting. If you shift any signal by the amount t naught in the right hand side or in the left hand side, so it is x of s e to the power minus s t naught, and you can see that the ROC does not affect by the time shifting. So if you have the signal x of t plus t naught, then its Laplace transform is x of s e to the power s into t naught. So it is now plus sign because it is also here plus sign. So it is also the plus sign. Okay. Now shifting in the S domain. Shifting in the S domain means if you have the multiplication factor as the exponential term. So if you have the e to the power s naught into t, so if you have e to the power s naught into t into x of t, then it is shifted by s minus s naught. And if you have e to the power minus s naught into t, then it is shifted in the Laplace domain by s plus s naught. Okay. Next is time scaling. So x of t is having the Laplace transform x of s. If you scale the signal by factor a, then its Laplace transform is 1 upon mod a x of s by a, where the ROC is a into r. So the ROC will change by the factor a. Okay, so it depends on the value of a. Now, time reversal property, if x of t is having the Laplace transform x of s and its ROC is r, then x of minus t will have the Laplace transform x of minus n, and the ROC will also be the mirror image. So you can see that this is the mirror image. This is previously minus a, and when you fold the signal, the ROC will be from the plus a, and previously it was right sided, now it is left sided. So it is also the mirror image. Now the conjugation property, if you take the complex conjugate of the signal x of t, then its Laplace transform will also be x of complex conjugate of s complex conjugate, and the ROC does not affect by the conjugate property. Now the convolution, if you convolve the two signals in the time domain, then in the Laplace domain they will get multiplied. So if you are convolving the two signals in the time domain, then in the Laplace domain they will get multiplied, and their ROC will be at least R1 intersection with R2. Now the differentiation, if you suppose differentiate any signal with the time domain, in the time domain, then you have to multiply it with the s. Okay, d by dt of x of t, that means it will be getting multiplied with the factor s, and it will have the ROC containing r. Now suppose you multiply with the factor t in the differentiation in the signal x of t time domain. So you can write that this is t times of x of t. So this is minus 1 to the power 1 to the power 1 ds of xs. So if you write suppose t to the power n x of t, so it can be written as minus 1 to the power n dxs of ds to the power n. So if you multiply the t with the x of t, then the minus 1, and you have to differentiate in the s domain. So this is known as differentiation in the s domain. Now integration in the time domain. So if you integrate the signal in the time domain, that is x of tau from minus infinity to t, then it is x of s divided by s, and ROC will contain the R intersection with the real part of s greater than 0. This is the property. Now coming to the LTI system analysis. So suppose we have a signal x of t. Okay, if suppose we have a signal x of t. Okay, suppose we have a signal x of t and output is y of t. Okay, and we have the impulse response as h of t. Then y of t is equal to x of t convolved with h of t. Okay, so if I take the Laplace transform, okay, so from here, if I take the Laplace transform, we will get y of s multiplied with x of s and h of s. So what is the transfer function? The transfer function is h of s is equal to y of s divided by x of s. So this is known as transfer function. Okay. Now causality. So for a causal LTI system, if the LTI system is causal, the impulse response is zero. So if you want to prove a LTI system to be causal, then ST should be zero for t less than zero. If this condition satisfied for any LTI system, then you can call that LTI system as a causal LTI system. And thus, because t less than 0, that means your signal will only exist for t greater than 0. So you can say that the signal is right-sided. So the ROC associated with this type of transfer function will also be right-sided. We have already seen for the right-hand side signal, the ROC is also right-sided. So the converse is not necessarily true. If the system is causal, then the ROC will always be right-sided. But the converse is not true. That means if the ROC is right-sided, so we cannot claim that the system will also be causal. Okay, remember that if the system is causal, then the Laplace transform will have the right-sided ROC. But the right-sided ROC doesn't mean that the system is causal. But this can also be proved. This can also be done if the Laplace transform is having the rational transfer function. Then you can say that the causal means the equivalent to the ROC of the right side of the rightmost pole. Now stability, if you want to say the LTI system as a causal and the second as a stable. So if you want to represent the LTI system as a stable, then you have to take the impulse response and from minus infinite to infinite. So that means you have to prove it as a finite value. When you integrate it from minus infinite to infinite, then you should get the finite value. In that case, we will say that the Fourier transform will also exist and ROC will include the j omega axis because the h of t is less than infinity. That means the system is stable. So if the system is stable, the Fourier transform will also exist. That means the condition of the stability is that when the ROC will include the j omega axis, the system will be stable. So an LTI system is stable if and only if the ROC of its system function include the j omega axis. Location of the poles for causal and stable system. A causal system with the rational transfer function h of s is stable if and only if all the poles lies in the left half of the S plane. Because when all the poles lie in the left hand side of the S plane, then only the ROC will be right side of the rightmost pole and it will include the j omega axis. Okay. Now, guys, the we have revised the Laplace transform. Now, this session will be continued in our app. So, quickly you can join me in the app.